Okay, so this is fourth period review video. We'll start at number 2 and do every third one after that. As always, check the Google Drive links for the other videos for the other problems. Number 2. Point P has polar coordinates 10, 5 pi over 6. So rotate 5 pi over 6 and go out 10. Maybe you don't have to draw the picture, but maybe it helps. Which of the following is the location of point P in rectangular coordinates? Okay, well, even just looking at the picture, x should be negative, y should be positive. So x negative, y positive. B works. D is wrong. A is negative, positive. C is positive, positive. So C is out. So I'm down to A and B. If I draw my picture right, which side length is longer, x or y? Just looking at the picture. X. So I look at my options, and 5 root 3 is bigger than 5. So I know it's A without really even doing the official stuff. The official stuff is x equals r cosine theta, y equals r sine theta. 10 cosine 5 pi over 6, 10 sine 5 pi over 6. But with multiple choice, a lot of times you don't need to go through the full length thing there. To come up with the answers. So I did it kind of the shortcut way first, and then the sort of official longer way second. Number 5. Which of the following is the graph of the polar function 3 cosine plus 2 in the polar coordinate system 0 to 2 pi? Okay, so I know I'm on the positive x-axis. They're all on the positive x-axis. 3 plus 2, but the 2 is the circle part. The 3 is the loopy part, so this is going to have a loop. Or I could just start graphing it and say 3 plus 2 is 5. That's sort of the max point on the x-axis. So already I'm down to C and D. The sides are the number that's by itself, 2. I'm still looking good for C and D here. Loop, or it's definitely not a cardioid, it's got a loop, so it's answer choice D. Maybe there was a quicker way to do that. If you noticed it had a loop right away, you would narrow it down to B and D, and then you could plug in a few points and figure out which one it is. Number 8. The graph of the polar function 4 cosine theta plus 3. Which of the following is true? Okay, for values between pi over 2 and pi, that's on all of them, correspond to which portion of the graph? Okay, well, let's plug in pi over 2 and pi and maybe other stuff and see what we get. So if I plug in pi over 2, pi over 2 plus pi over 3. 3/6 plus 2/6 is 5/6. That's going to be negative something. 2 root 3. If I plug in pi, you know what? I probably need to plug in something between pi over 2 and pi. So that'd be like 3 pi over 4. 4 cosine 3 pi over 4 plus pi over 3. Ugh, this is getting yucky here. is that going to work out? 9/12 plus 4/12 is 13/12. I don't really like that, but I know that 13/12 is a little bit past pi, so that's definitely negative. And then at pi, that's an easy one. 4 pi over 3 is 4 cosine. 4 pi over 3 is negative 1/2. So that's negative 2. So all those values are negative. So if I rotate pi over 2 and then go negative, that's right here. I rotate 3 pi over 4, but it's negative. That's right there. And if I rotate pi and go negative, that's right there. So we traced out some stuff in the fourth quadrant. Yeah, I don't know. Is there an easier way to do that? Maybe. But it just seems very straightforward to check some points between pi over 2 and pi and see where you land. 8 plus 3 would be 11. Which of the following is the graph of the polar function for 2 cosine 2 theta? Oh, between negative pi over 2 and pi over 2. So be careful. If you just think 2 cosine 2 theta, that's a 4-petaled rose. But that's if we go 0 to 2 pi. Let's see. All of those are 4-petal or some portion of a 4-petaled rose. So I think another table of values is probably in order here. So 2 cosine of negative pi. Cosine of negative pi would be negative 1. That's negative 2. So let's just plot points again. So if I rotate, it's tricky here. Rotate negative pi over 2. And then go back 2. Or up 2. So A has it. Negative pi over 2. Back 2. B has it. C has it. D does not have it, so D is out based on that point. Let's check 0 and see what happens. 2 cosine of 0. Cosine of 0 is 1. So if I rotate 0, I should be out 2. Graph A has it. Graph B has it. Rotate 0 out 2. Graph C does not have it, so graph C is now out. Alright, getting closer. Let's try pi over 2. 2 cosine of pi. Cosine of pi is negative 1. So that means I want to rotate pi and go out negative 2. Rotate pi, go out negative 2. Rotate pi, go out negative 2. Uh-oh, both of them have it. So which one is it? Is it the entire graph or is it only part of the graph? Maybe I should check something. Let's see. Where would it not show up? I think I need to check something in between. I don't know if that's going to help if I check negative pi over 4. So I'm going to end up with 0. And both of them are at 0. A to B to C. Oh, wait, I put that in the wrong spot. C's down here. But if I go from A to B to C, like that's as far as I can go. I'm not allowed to go any further. So if I think about the direction of this thing, from A to B to C, like that's as far as it goes. I shouldn't catch all those other points. So I think it's B. which makes sense in my mind because that's only going pi, and usually we go 2 pi. Now we're only seeing half of the picture, so that kind of, I think, syncs up in my brain. Number 14. Uh-oh, a lot of words. Consider the graph of this polar function. Which of the following is true? So what happens from 0 to pi over 6 is the question. So let's graph it from 0 to pi over 6 and see what happens. Although I know already this is a, let's see, limmason with a loop. I know that's what it looks like, but from 0 to pi over 6, I don't know what that looks like. So if I plug in 0, 2 sine of 0 minus 1 is negative 1. If I plug in pi over 6, 2 sine pi over 6, sine of pi over 6 is 1/2. So this ends up being 0. And I don't think anything crazy happens from 0 to pi over 6. So from negative 1 to 0, the polar function is, hold on, from negative 1 to 0, that's increasing, right? It's a weird way to, again, when you're negative, you just got to be extra careful. So we're increasing, because we went from negative 1 to 0. But the distance, if we went from 1 away to 0 away, the distance is decreasing. Like we're hitting the more confusing parts of the test on this worksheet. Number 17. Number 17. Oh, that's definitely an AP type question because, like, I have no idea what that graph looks like. And it's extra challenging or confusing maybe. Consider the graph of that. If you don't look at your answer choices, you're like, I don't know what the graph of that looks like. But look at my answer choices. They all are asking about the limit as theta goes to infinity. In fact, those are all 4 different answers. So if I can figure out what the limit is as theta goes to infinity, I'll have my answer. Limit as theta goes to infinity. So 3 times a really big number cubed plus 50 over 2 times a really big number squared plus 5. So it's been a while since we did one of those. What's 3 big cubed plus 50 divided by 2 big squared plus 5? What's happening here? Is the top getting bigger faster, or is the bottom getting bigger faster? Or is it one of those where I take the coefficients? Yeah, because of the cubed, the top is getting really big, the bottom is just getting kind of big. Yeah, you didn't like that. Really big versus kind of big. But if you cube a big number, you're going to get way bigger than squaring a big number, so we're headed to infinity. So my answer is D, and I really don't even need to read the rest of the problem. Because the limit goes to infinity, points are getting increasingly distant from the origin. Yeah, because R is getting bigger and bigger, so as you rotate around, this thing is gradually getting further and further out from the origin. Okay, again, definitely some AP style questions in there where we throw a equation that you've never seen before on there, but you have the tools to analyze things and figure out what it's asking. Oh, and since I said it on the other videos, don't forget to press like and subscribe so you don't miss my other exciting videos. Comment down below for what you think I should talk about next.